Hello everyone, I'm Tasfahun Alamu. I'm a senior barley breeder at Ethiopian Institute of Agriculture Research. In this video, I will show you how to analyze different experimental design that include analysis of variance and its appropriate mean separation. Now we'll open a new R script sheet, and then we clean everything here. Okay, so the first thing we can do is can set our data. We can set our working directory. That can be done here. See, set working directory, choose directory, and this can be choose from here. Yeah. So now we will start to analyze our data. So the first design we'll consider is general information. Let's see the general information for data analysis. The first thing is import the data. The second part will be identify factor or treatment variables that could be as a source of variation. The third one will be change factor variables to factor. The third one will be define the mathematical model to be analyzed. This one, sorry, the fourth one for the step. And the fifth step will be change the model to our formula. And then finally we'll go to analysis. Okay, so now we will start with the experimental design CRD, or completely randomized block randomized design. So here the first part will be import data. Import the data. So here I will import one of the data from my data set. So I will import it from a text file. I have this one is example one. So this is the RCBD data. So here we can import the data like this. This one is CRD, for example. You can give the name CRD, and then we'll import it. This data have 135 observation and 9 variable. It is 3 location yield data, 6 location data. So for CRD single location, we only need 1 location analysis, so we should subset the data. So CRD1, it can be CRD1 equals, it can be the CRD square bracket, and then we will CRD, then we'll take the location, and here we can make, for example, Bakwaji one of it, and then we can subset this one. So this data will have only one data, that is 45 observation, but it has 99 variables. Okay. So then after we after import the data, then we should identify the factor variables. To do so, it is possible to see head CRD1, and in this CRD1 we'll see that the header will show the location, year, treatment, and replication. So in this case, our variables looks like, for example, location is since it is a single location, we don't need location. year also, since it is a single year, we don't need. So for CRD only we need TRT treatment. So our variable will be treatment. So the next part is change factor variable to factor. So this can be done like this: CRD1 we call treatment, and then equals factor, and then CRD1 treatment. Okay. So with this we change to factor, and then finally define the model or mathematical model. In this case, our mathematical model like this: Yij mean plus treatment effect and plus error will be our model. So we will change this model to R formula like that, means response variable with treatment will be our R formula. So now we'll go to the analysis. So here we use linear model or AOV function we can use. So here we can press tab and see what will ask us is defines the formula. So in order to define the formula, we will select the trait we want to analyze. For example, we want to analyze the data yield. So we will see yield, and then we will select the treatment is here, TRT dot, and then the next part will be this the data CRD1, and then we will save it here as AVR or AVC, or AV1. Can give any name we want to the name what is interested for us. So here after this we will see the ANOVA AV1. Then the ANOVA table shows that there is no any significant difference among treatments for this trait for yield. So but the analysis of variance looks like this. Okay, the reason may be high variability between treatments will be considered, since as you see here, the residual is very big one, even it is twofold as compared to the other one. So it is really our experiment is not too good, it's too bad. So we'll see this one. Okay, then after we do this, we can check also for ANOVA assumption if we are interested. Check for ANOVA assumption. So this can be done graphically. For example, can set parameter m from in order to plot 4 graphs at a time, and then we can plot the graph AV1, the output of the ANOVA. Then we'll see it how much it looks like this. So there are some different varieties here, factors, but it's more or less good. There are some variables also here. Okay, so this is the normality check, and also you can check statistically this one using Shapley test, and this can be done. We can extract the ANOVA and put for them the residual. So here, as you see, p-value is a little bit statistically significant, so that's slightly okay. And the homogeneity can be checked also using Levin or Bartlett test. So this one can be given like this. You can use yield versus TRT, and the data will be CRD1. Yeah. So this one will be p-value is 0.83, so there is no any highly variability, so there is more homogeneous, so there is homogeneity, but normality is a little bit affected. Okay, so after that, since there is no any significant difference, you cannot go to further for variability mean separation. But we can see, for your information, you can do the mean separation. So this means separation test can be done using the library agricole, or means can be also done, but in this case we use agricole. So agricole have its different functions that can be used for mean separation, like LSD test, Duncan test, and Tukey test. So I will use LSD test, D test. So for this LSD test, we need only one. Is if we have analysis variance already done, we can give the model or either the response variable, the observation of response variable. So here already, since we have done analysis of variance, we can put the output here, and then we should write here the treatment name we want to test for it, and then we can give console true in order to see the output here, and also we can group, also we can see the group here. So after that we can run it. So here we'll see this output. So in order to get the other statistical parameters we are interested, ls mean, we can save this output, and then from this one we can take the statistics that will show us the mean square vertical of the MCV and the LSD value be present. So the LSD value, as you see here, is very big one. It is almost 18 quintal. It is a really exaggerated one, so that there is a problem in our experiment in this case. High variability. So this is how we do the analysis of variance for CRD, and you can substitute yield by different traits, and you can do for other traits also. The second one is RCBD. Second one will be RCBD. The first one is here. So the second one also the same data we can use from the above one, and also you can use it to analyze the data. So the only thing we can do here is, since already you have changed the factor, so you don't forget, is one to remind you. First is import the data, and then identify factor variable and change to factor, and the third one defines the model. Here as RCBD, the model will be mean, block, treatment, and AIJ will be the model. So this R formula for this will be response variable with a small snake, block effect plus treatment effect will be the R formula for the analysis. So here we can use the LN, and also you can define the performance here, yield, and then we have TRT dot plus rep. Here is, for example, CRD 1 rep dot, then you can give the data CRD 1, since we have the same data with similar data we use for this analysis. So then we can save this one as AV2, the output, and then we can see the ANOVA table using AV2. As we see, there is no any significant difference among the treatment, even the replication, there is no any difference between replication, so our replication is not efficient enough for the analysis. Okay, or we can test this one, for example, from other data, RCBD. You can use CRD subset, CRD $location. Can select ARC, Maybe that is better a little bit. Then we can here put RCBD so that we can analyze it, and then we can see there is no any significance. Oh, sorry. Then from the data, after the data, we should change factor variables. That is RCBD treatment equals factor RCBD treatment, and then RCBD rep factor RCBD rep. Yeah, now when see it, we have significant difference between treatments, but there is no any significant difference among blocks. So here we can make a test ANOVA function, especially the homogeneity and heterogeneity. So we can plot it if interested, like this, for example, like par M from C 2 by 2, and then you plot AV2. So first run the first parameters, and the second we'll see this one is the output what we have been observed. So as much as possible when you see it, we use more or less homogeneous variance, and also normality is also satisfied in this case, I think. So statistically you can text or also Shapril test like this AV2 and residual, then since the p-value is very high, 87, and also you can use Bartlett test for heterogeneity of error variance. This can be done as like that of yield, and then TRT dot, and then data will be RCBD. Good. The Bartlett test also show non-significant, so it means homogeneity of the error variance is satisfied in this case. So you can go now mean separation test. So for this mean separation test, we can use also the same LSD. So the model we will provide is AV2, and then the treatment will be tested will be TRT dot, and then finally console will be true. We can want to see in the field, and also group we want to see the letter of this place. So we'll see run here, and then this shows that there is significant difference and everything is done right. And finally, if you are interested to get some statistics, LSM1 can do the like this, and then under LSM1 we'll extract statistics. So this statistics will give you mean square of error, degree of freedom of error, mean, CV, t-value, and also LSD value will be provided here. This is the analysis of variance for the RCBD. So in this case, if you are interested to in order to use also another trait, you can change here plant height, and also other traits can be substituted here and analyze it will be it can be helpful. So the other parameter we are interested to analyze another design is alpha lattice or simple lattice. The same thing. It's the same thing. Alpha or simple lattice design. So here, what we're gonna do is we should import the data from our data. So here is our data is example data. So from here, the example data, we will select the alpha lattice data lattice. So we'll bring as lat. So we'll import it. Okay, so the first thing after we import the data will be head lat. This is as you show it. There are different location here, var name, treatment, plot, block, rep we have. So the second one will be identify the factor variables. Here the factor variables can be location. Year is not in this case because only we have 1 year data, so it doesn't necessarily define it. The other one is treatment. The other one will be rep, and the other one will be block. This will be the factor variables. So we should change this factor variables into factor. Change the factor variables into factor. So we can change it like this: lat, log, factor, lat, log. The next one will be lat dollar. We will select treatment, and this will be factor. Then lat with block, factor, lat with block. Then the other one will be lat with rep, factor with lat with rep. So these are the factor variable we are interested to change to factor. Then after that, it is possible to check if the structure is already changed, like this. For example, if you see that all are or what have been location in changed, treatment is changed, rep is changed, and block is changed, so it is satisfied. So the fourth one will be define the model. Define the model. The model will be defined as this: ijk. We have mean, we have treatment, we have rep j, we have block within rep bkj, and then we have error. This is the model. Then the R formula can be written as response variable, as treatment effect, as rep plus block within rep interaction will be the model. Then analysis. In R, this analysis can be done in two ways. The first analysis can be done using the package called agricoli library. Agricoli, yeah, the library agricoli, and this library agricoli will have a function called partially balanced incomplete block test function. This function has a function that is practically used to analyze alpha and simple lattice design. So here we can attach with data. That is here in the location case we have two levels location, so we should subset our data. Lat 1 equal lat square bracket lat total location arc, then comma. Then here we'll put lat 1, and then the block will be block, the treatment will be TRT dot, replication will be REP dot. Then the response variable is yield, and the block size will be here is the observation as we see is 8 by 10, so the block size will be 8. So I should change call name lat1. Sorry, the name is not as I put it. 10. So here this one. Okay. Then we should give the name. That name is yield, because in the data we'll have the naming is not as such appropriate, so I changed it. So the analysis can be done like this. In this case, first we should use partial balancing compliant block design test, and then we define the block, provide the treatment, provide the replicant, the yield, and then the block size will be defined. So it will be analyzed here like this. In addition, it's possible to give this one to make analysis with the lattice. The design one can be provided from this the object, but the yield data should be given separately, so that's why I've given you this. So I will give this one and I will save using the name lat out. So from this lat out, what you're gonna do is lat out ANOVA. We can see the ANOVA table here, and also other out lat out. Probably you can get some parameters, means, groups, everything will get here. So this is a group of the data, so this will be the output. But as you see it, since it is the number of genotypes is very big, so it doesn't make sense to see all this milk comparison purpose. So this is not the good idea, but we'll see in the next part. Okay, so using the model, the ANOVA, using the model for lattice or alpha lattice, this can be done like this. So you can lay a model and then you can use formula. For the formula, will provide yield, and then the first one will be TRT dot treatment, and then we have rep, and we have a block with interaction with rep, and then finally we'll give the data will be lat1. Okay, then this one will be saved as AV3, for example, like this. The name can be given. This is the one I will do it. So I will analyze, and this one is done. Then Eva, Avon, ANOVA will be used to see the ANOVA table. This is the ANOVA table. So as you see, there is some significant difference among the different treatments. Okay, then next, after this, we can go for the mean separation. For the mean separation, in this case, we will use we use other function, not LSD like the above ones, because this data, this field design or layout, alpha lattice and lattice incomplete block design, since due to the block within rep is not complete, so that the mean data should be adjusted mean, not the arithmetic mean. So the adjusted mean should be first produced, requires the adjusted mean. So this adjusted mean can be produced as using the library package called means. Okay, in this means we have a function called mean. So we put the ANOVA model first, and then we write the variables that should be estimated for the mean. So M1 will be the output. So this we'll use the AV3 output from the ANOVA, and then we'll provide this the variable that we want to estimate the adjusted mean. So we'll run it. So this is done, and then in this case, as you see, we have almost 18 genotypes. So show the mean separation will be more complicated. So instead, the best part is to use a contrast from AMM means that will compare for us each treatment with respect to a check or a standard check. So that we use contrast. Then from the contrast, we'll give the output of the AMM mean, and then we should provide like this treatment dot versus dot control, and then we provide the reference. Which one is the reference? So this reference can be, for example, in our case here is the 80s genotype. So the AMM will produce, will test each observation in relation to observation 18, so that it will provide for me such type of output, very interesting output. So everybody will be compared with the mean of the standard check. It will be the effect estimated and then the standard error, and then finally will give you the p-value. So this p-value will be provide us with which one is significant, which one is non-significant. This is what you're gonna do. And the other design, what we've been going to is augmented design. This design is used especially for breeders when you have large number of samples with small number of feed, so that we use different checks in the same in different blocks. So the variables will be different. The new treatment variables, the new treatment varieties or genotypes will be different. Instead, we have common checks across all the blocks. So the first thing we can do is here is the same thing as we have done in the above part. We import the data. So this import can be done using import here, Excel, and then we will go to browse here, example dot. And from here we will select the augmented design data. This is aug. So we'll import this data. This one is our data, and then we will go identify. Then the next part is identify the factor variable. Identify the factor variable. So here we can see how the factor variables are head, aug. So here we have more than 10 variables here. So in order to see this one complete as data frame can be used. Here, for example, we have the factor variable location, and this one will be treatment, and then block. So these are the factor variables. So these are the factor variables are location, TRT dot, and block. So we'll change these factors into factor aug location factor aug location aug treatment factor aug treatment, then aug block factor aug block. So this is done, and you can check if it is changed using aug. That's already changed, as you see here. Factor. So since this is two location data, so we will subset for one location data. So what's called aug1 aug location arc Then we'll take all the column, and then the analysis will be like this: ANOVA, that is LN, and then here we can take, for example, dice to maturity, DMA, and then you can put TRT dot plus block. Data will be OG1. Then this output will be saved as AV4. Yeah, then the ANOVA can be checked using this one. So this is a seat. There is significant difference among treatments. And then we can make that means separation test. Okay, so this means separation test can be done like the previous one, like simple lattice, since we need only here is adjusted mean. Since it is also augmented is also incomplete block design, so that it will need adjusted mean. So that can be done. So that can be done using the library AMMean. Then AM means we will go AV4, and the one we want to compare is to RT dot, and then we'll save here AM2. Okay, then this one can be we can see also the same thing as we have seen in the simple lattice. We can see the contrast. So the contrast will be like this, AM2, and then we will see the method like this one, the one treatment versus control, and then we'll give the reference. The reference, this is the level of the treatment is about, for example, you can see the level of the treatment, level OG1 TRT, so 94. So you can use as a reference the 94 genotype as a standard check. So here, as you see, will produce for me the test of each genotype in relation to the standard check. That will be an interesting one to compare with each other. Okay, this is okay. And the other part is for single location analysis. Also, you can do using analysis using agricoli package of DAU test function. So this DAU test function will require block, treatment, a response variable will be yield. The other one can be done. Okay, leftover. There here we can attach with OG2, OG1, and maybe you can see it. If not, we'll see how it's gonna do. Yeah, yield is not found. So it means this attachment can be done, but here we will only put the complete data of the yield. Instead, the other data can be accessed from with OG1. Okay, so we'll define OG1. Here is also OG1. So maybe you can remove this one and this one. Oh, sorry. This should be DMA. It's my fault. So this can be attached with org1, and then this can remove here the design. In this case, I think since the program is you should provide the design part like block treatment can be accessed from this file, but the yield part should be, or the response variable part should be come with a complete list of. So that's why I put here org1 DMA. Then this is the analysis. It's done. So in order to see the output, it is better to produce LSMG, and we will save it. And then for LSMG, we can extract the mean, the group, and the comparison here also. This, as you see, there are a lot of letters here, so it makes things complicated. But in this case, it's more interesting in this case than the other one. So this is the analysis. So in this manner also you can analyze augmented block design. So this is what I have for all the breeding designs, and we will see you again by next video. Thank you very much. See you. Bye bye.